Welcome to the remote CITP seminar. I'm Jonathan Mayer. I'm a faculty member at CITP. Today we're fortunate to be joined by Serge Egelman from ICSE and UC Berkeley. Serge is the research director of the Usable Security and Privacy Group at ICSE, and also holds an appointment at Berkeley Electrical Engineering and Computer Sciences. He leads the Berkeley Lab for Usable and Experimental Security, or BLUES, which is by far one of the best acronyms for research groups in our area. And Serge's work focuses on privacy, security, and the intersection with human-computer interaction. He's done particularly seminal work on browser warnings, mobile app privacy, and COPPA, the Children's Online Privacy Protection Act. He's won more Best Paper awards than I can remember, and he completed his PhD with our friend Lori Craner at Carnegie Mellon. I'm really looking forward to this talk. I hope you all take as much away from it as I do. I have to give the obligatory disclaimer: this talk is being recorded for posterity, so any mistakes we make are, well, they're there. With that, let me hand it over to you, Serge.
Thanks for the lovely introduction. Can you see my screen okay? Yeah, excellent. Yeah, thanks for having me. I'm Serge Egelman. My research interests lie between human-computer interaction and privacy and security. And so most of the types of stuff I've worked on has to do with the interplay of human factors and how people make privacy and security decisions. Over the past 10 years, my lab has probably spent a significant amount of time looking at mobile privacy specifically. And so that's what I was going to focus on in this talk for today, mobile privacy and what that actually means for compliance. And so stepping back over the past 10 years, the beginning of when mobile devices started to become popular consumer electronics, there was some nascent research on this. And in the beginning was the word, and the word was permissions. Most of the privacy and security research that looked at this early on had to do with permissions in terms of, users on Android specifically were shown these dialogues at install time that listed what sort of, privacy and security behaviors the app might be allowed to perform if it were installed on the device. And so my group started out by looking at, do users actually understand these disclosures? The mobile devices, this was around, 10 years ago, they were starting to become popular. And this was an opportunity for OS designers to actually build privacy and security into the OS in ways that hadn't been done on desktop operating systems. And so we studied these, and at the time, one of the big security threats was malware that would send premium SMS messages to run up charges on a user's bill. And so, we wanted to look at this scenario. How might a user figure out which app is malicious if this were to arise? And so at the time, there was a process. And so, from Android, you could, click the button to open up your list of apps. You could go to the settings, click it to open it and look at the list of applications. From that, you can scroll down and find the Manage Applications button, and then that lists all of the particular apps, and you can go through app by app, clicking this, viewing their settings to see which permissions they have. So 12 steps in all to figure out what an app is just capable of. And so we studied this, and sure enough, we found out that, between a lab study and an online survey, we found that most people have no idea what these actually mean. They don't pay attention to them when they're presented, and they don't really understand what they do. And another, even if people do, were to understand and notice these things, they don't actually disclose how the data will be used. And this comes up a lot. So frequently I get asked from, people outside of, the research community, privacy research, they want to know, how can I identify apps that have good privacy practices? And, clearly just looking at permissions isn't really a sufficient way of doing this. And so, I tell them, it's simple. You just need to instrument the permission protected APIs, disassemble app binaries, and then perform deep packet inspection. And so, I joke about this, but, really this is what one would have to do to, beyond a reasonable doubt, show that, an app, what an app is actually doing with their data. Instead, what we do have beyond the permission system is the notice and consent framework, which as basically just means read privacy policies. And so what does that actually look like for a user who wants to make decisions about privacy? So let's say they're shopping for a new app. They look at an app from a list of popular apps. They're going to install TikTok. For the notice and consent to work, they need to know to scroll all the way to the bottom and read the privacy policy. And read it they will. It's long, and this is just to decide whether or not they want to install this app. And so, this is a well-known problem. So this policy in particular has over 5,000 words. It's written at a high school reading level, and it would take the average person more than 20 minutes to read. But as I said, this is well known. This was studied 10 years ago, more than 10 years ago, and at that time, that study just looked at website privacy policies, and calculated that if the average web user read the privacy policies for every site that they interacted with, they'd basically be spending over 200 hours a year just reading privacy policies. So essentially, a job basically. But again, similar to the permissions, they don't really answer all of the questions that consumers actually have. So, one question that consumers often have is, what about third parties? So app privacy policies will say, the data might be shared with various third parties. The intention is then that those third parties will have their own privacy policies. And so it's up to consumers to find all of the privacy policies to figure out just what might happen with their data. Of course, looking at this in practice, the privacy policy will say things like that data will be shared with business partners or advertisers, and they don't actually name the third parties because they have no obligation to do so. And so unless you're actually decompiling the app and seeing, where the network traffic is actually going, there's no way to actually identify the third parties, which means you can't get from A to B. You can't figure out whose privacy policies you even need to read to even consider installing the app. And so, privacy policies, are a tool. They're an imperfect tool, but they're actually, more or less legally mandated now. So, in 2000, when COPPA, the Children's Online Privacy Protection Act, came into effect in January of 2000, it required, any child-directed services to post a privacy policy. And basically what that means is, companies collecting data specifically from children under 13 had to post policies. So, that's one sector for, child-directed content. In 2004, this expanded with the California Online Privacy Protection Act, which required that if a company is doing business with consumers who are located in California, then, they need to post a privacy policy for those services. This was restricted to just consumers in California, but, if you think of, say, the iOS App Store, the Google Play Store, clearly they have customers who are located in California. And, since app developers, to my knowledge, can't actually geofence within, the app market based on state, you can do that on the country level, but I'm not aware you can do it on a state level. Basically, any app that's centrally distributed is going to have to comply with CalAPA and post a privacy policy. Privacy policies are also, legally mandated now in the EU under GDPR, and under CCPA now they're double plus mandated in for companies doing business with people in California. So, the question is, are apps actually complying? Are they complying with their own privacy policies? Are they complying with relevant laws and regulations which govern the content of those privacy policies and other practices? And so, my group set out to answer these questions about 4 or 5 years ago. We had been working on building a lot of instrumentation into Android because we wanted to measure how often apps use permissions. We did instrument. We have a fork of the Android OS that we maintain that has hooks for all of the the APIs that handle sensitive data, so that whenever you run an off-the-shelf app, we can see automatically exactly what types of sensitive data it tries to access. In conjunction with that, another project going on at ICSI at the same time was called Lumen, which is a user space traffic monitor. Basically, it uses the VPN interface to do man-in-the-middle attacks, using its own signed CA cert that you install on the phone. So combining these tools together, we've basically built a pipeline for running apps, seeing what data gets accessed, and then where it gets sent. And using this, we've been generating some data sets where we download the apps, we run them on our instrumented devices, and then using all of this instrumentation afterwards, we can then see what data was exfiltrated, where it was sent to, and then based on those API endpoints and the SDKs that are present, we can infer what the data might actually be used for. For instance, if it's going to an advertising API versus an analytics one. And so, over the past couple of years, we've basically set up a test bed. It looks kind of like a click farm where we have a whole bunch of phones that are all daisy chained together, and we then push apps to them and then automatically test those apps. And then, afterwards, since these are our devices, we know what information to look for, such as personal information that we have pre-stored on the phone, such as an email address, phone number, location information, and so forth. We also have a listing of all the persistent identifiers, and so we can search the traffic for all of this known data, as well as looking at various permutations of it, such as encodings like base 64, different hashing algorithms, and so forth. And so we've built this test bed where we download the apps, we run them. In some cases, we simulate the user interactions using a UI fuzzer, where we basically just generate random taps, swipes, and so forth. But we also can test apps with real user interactions. And we push all of the logs to a database, which is then accessible by API and on our website. So here's just an example of what it looks like behind the scenes. This is we've spun part of this off as App Census, which we do now testing on behalf of various entities. So this is what it looks like internally. We can specify what country to test the app in. We have phones in several different countries. We can specify the type of device, as well as whether we want human interaction versus the fuzzer to do it. And so if we have real human interaction, we've recently developed this basically a remote desktop solution. We have an HTML5 remote desktop client, which is connected to the phones, which are located in whatever country we're doing the testing in. And then the user who's doing the testing can basically just interact in the browser with the app. And so we've been doing this for crowdsourcing, real user input. Afterwards, we generate these reports, which explain, what happened to the data, as well as, the testing conditions. So, we can see which third parties were contacted and what data was sent to those third parties. So in this case, DoubleClick was seen receiving the Android advertising ID. We also detect SDKs. So using this, we've been doing a lot of work to just look at privacy compliance at scale. One of the early, reasons why we thought, this would be an interesting thing to look at, came by basically, it was serendipitous. We were looking through our data and doing some queries to see, what are the most prolific sharers of different types of identifiers? What are the most prolific sharers of, location data? And in doing that query, we observed that the CVS app was sharing location data with 40 different third parties. At the time, this was, I think, this was probably one of our first test cases when we were just starting to generate data. I assumed that this must be a bug in our code. There's no way there are this many, location recipients from the app. But, upon closer inspection, looking at the traffic, what we found was that the app was basically a series of web views. Web view is just a lightweight web browser widget. And so the app all the app content was just web pages that it would load from CVS's own servers. And the problem here is that whoever wrote this app, which actually not appears, from talking to people at CVS, we subsequently found that they'd hired a contractor to build the app for them, several different contractors. And one of them decided to put the GPS coordinates into the user agent string for whatever reason. And that had the net effect of any third-party content that was loaded on one of these, in one of these web views would receive the GPS coordinates. And so the second lesson learned from this was the importance of posting information about technical contacts on web pages, because I spent about an hour of my time trying to find one to report this bug to CVS, and having given up, I finally just sent an email to their customer care, who promptly sent a poorly written form email back to me saying that they don't share location with anyone. And so, being at a dead end, we set up a blogged about it, and a bunch of journalists picked it up. And sure enough, CVS fixed it within a week. So, there are a lot of lessons from this. But, one of the lessons was that, app developers are often just unaware of the privacy issues that are occurring in their apps. And so while a lot of the research has focused on, well, a lot of my research previously had focused on users and consumers of these technologies and helping them make better privacy decisions, it appears that oftentimes when their privacy is being violated, it's not necessarily due to malice, but often that developers just don't understand what their apps are doing. And so, this could actually lead to serious ramifications. And, in the case of CVS, it was, it led to some bad press. They fixed the app, and, and the issue went away. But, in other cases, this could have, it could bring other, more serious liability. So here's another example of an app we identified early on when we first started building this infrastructure. So here's Animal Paradise by Baby Bus. We observed it transmitting lots of different identifiers and location data, all unencrypted. In this case, in yellow, I've highlighted the app is sending data to Talking Data, which is an analytics company. It's sent over port 80, so unencrypted. The numbers in blue are all sorts of different persistent identifiers tied to the device, such as the advertising ID, IMEI, serial number, and so forth. And then green lists current and prior Wi-Fi hotspots that we had connected to, which can be used to infer location data. So, this also wasn't the first time Baby Bus has been in trouble for this. A couple years prior, it was interesting that the FTC had actually sent them a letter about some of their apps' privacy behaviors that appear to be violating federal law. And so let's go into that. The U.S. Children's Online Privacy Protection Act has been around for about 20 years now, and it covers all online services that collect data from children under the age of 13. And so what that means is if you're developing a service that's specifically targeted at children, or you have knowledge that you're collecting data from children under 13, it's illegal to do profiling or behavioral advertising and collecting persistent identifiers for those purposes without verifiable parental consent, which is it's a whole nother thing that I'm not really going to go into, but needless to say, the monkey, which is what we call the UI fuzzer, pounding on the phone isn't sufficient to get verifiable parental consent, which means most of the behaviors that we observe are likely violations of COPPA. The data, when it is sent, also requires reasonable security measures, which we interpret as at TLS at a minimum. And so what we found was, looking at these heuristics that we came up with based on the law, it appeared that a majority of the apps in the Play Store appear to be violating COPPA in one way or another. And by and large, most of this came down to third-party SDKs. So a lot of SDKs violating Google's policies on the types of identifiers that can be collected, as well as SDKs that are specifically for behavioral advertising and profiling purposes. And then to boot, 40% of the data was sent without TLS. And so again, the point is that most of these violations were from third-party services. Also though, a lot of the behaviors that we observed, it wasn't that the platform, in this case, the Google Play Store, doesn't have policies of its own about these things. They certainly have policies. The problem is the policies aren't enforced through any technical mechanisms, which means that basically developers are, on their own in terms of whether they believe themselves to be following the policies and the applicable laws. And as we see that, developers don't really have a very good grasp of that for many legitimate reasons. So here, starting in 2014, 15, both iOS and Android rolled out this advertising ID, which developers are required to use for advertising purposes. And so this is similar. It's a software-based identifier that can be reset through the settings panel. And so that's equivalent to, say, clearing your cookies in a web browser. If you don't want to be tracked anymore, you can reset the ad ID. And so we found that most apps, though, were transmitting the ad ID alongside other non-resettable identifiers, which basically negates the privacy-preserving properties of this. And, again, this was all due to SDKs. So we see, some like Chartboost, Greedy Game, and Tapjoy that basically are, universally collecting more identifiers than they're allowed to by policy, which means apps that are embedding these SDKs are doing this. We also found that almost 20% of the apps are sharing identifiers with services that specifically say that they shouldn't be used in children's apps. So, at the time, Crashlytics, Mopub, Tapjoy, all of these ones had terms of service that said they shouldn't be used in children's apps. And when you read their privacy policy and the terms of service, it's clear why. So Mopub, for instance, says, you're not allowed to use the Mopub SDK in apps directed to children under 13. And when you read the privacy policy, it says that it's because they do behavioral advertising with the data they collect. And so doing that with children's data without verifiable parental consent would be illegal. So we studied this, we published a paper, and that had some impact. There was a lawsuit, there was a state AG who went after an app developer and a bunch of these SDKs. The New York Times sent a photographer who looked at my office and said, too many plants, not enough blinking lights. And so then I got my opportunity to visit the machine room for the very first time for a photo shoot. That was fun. But most importantly, Google actually changed their policies. So they, as a result of this, they announced a new policy that the ad networks included in apps can only come from a specific list. And these certified ad networks are certified for inclusion in children's apps because they all allow developers to disable behavioral targeting so that they can comply with COPPA. The problem, again, though, is that, again, compliance is totally self-certified. And, we'll see why. All of these, have different methods for, disabling the behavioral advertising or enabling the COPPA compliant mode. So here at the top of the list was Ad Colony. The user has to go into some dashboard and check a box to indicate that children use the app, and that will disable the behavioral advertising. There's a similar thing here for Chartboost. Both of these, by the way, to take these screenshots took, I believe, a minimum of 15 minutes searching around online trying to find developer docs. And that was specifically searching for these options because I know they exist. I can't imagine how much time, it doesn't seem likely that an app developer is likely to encounter this unless they're specifically looking for it. Here's another example of, here's Kochava, which is also one of them, and this actually lists code. There's a code snippet that developers are instructed to paste into their apps in order to limit the ad tracking. So, a year and a half later, I revisited this, and we found that, with these new policies and the scrutiny over the issue, compliance seems to have improved. So, collection of location information has reduced to about 1/3 of what we initially measured it at. And, same thing for data being sent securely. So, while it's at just under 16% right now, that's an improvement from 40% in 2018, which is good, but still not great that a significant number of apps in 2020 are still sending data unencrypted. But, with this self-certification, there are problems. So, there's still lots of use of unapproved ad networks in apps that are targeted at children, and it's because there's no checking that's done. It's based on the developer certifying they're not using one of these ad networks. But more importantly, the ad networks that are on the approved list are on the approved list because they allow the developers to configure them to opt out of tracking for children. But even when we look at that, we find that many of them aren't actually configured to do that. So here's one, Kachava, we found 36 apps that still sent data to Kachava, and none sent that opt-out flag that we saw in the documentation. So, the real problem here is that each of these SDKs has its own API and its own methods for, configuring it so that it's in compliance with the law. Here's an example. So Facebook ads, in their documentation, if again, you need to know to look for this, but they say that, one, Facebook ads simply, if your app is primarily child-directed, don't use Facebook ads, period. If it's mixed audience with an age gate, then you can use the age gate to decide whether to set the set mixed audience flag. And that'll indicate that behavioral advertising should be disabled. And that manifests itself in the traffic as an HTTP parameter of kappa equals true. And so let's look at this in, here was an app, Duolingo. It's a fairly popular app. When we tested this a couple of years ago, we saw that it was sending the advertising ID, which is the second value highlighted here as IDFA. And it was sending it along this flag with kappa equals false. And this was, this was in Duolingo, which at the time was in the, was listed as in the Design for Families app, which means directed at children. And so it should not be sending the kappa equals false flag here. And so we started to figure out, why this was doing this. In this case, you might have noticed there was a flag here that actually says that this was due to AdMob mediation, which is what, that's why Facebook is being called. So what this means is mediation, ad mediation is another technology where you have a mediation SDK and it's responsible for contacting multiple ad networks to try and optimize, which one's going to get the developer the best price. Normally, in the old days, you would dump in, SDKs for whatever ad networks you wanted. And those would be the only ones contacted. Now with mediation, you can add a mediation, SDK, and then that'll handle adding, lots of different ad networks to maximize revenue. And so that was what's happening here. So AdMob was being used for mediation, and you can look in the AdMob documentation. That also has documentation on kappa compliant treatment. And so for child-directed apps, it says if you're using AdMob, make sure to call the function tag for child-directed treatment. And so we did some binary archaeology. That's a term, a term of art that we use because we absolutely do not do reverse engineering, which is a defined term that yes, we absolutely do not do that. So doing binary archaeology, we see that in fact the AdMob SDK, one, the app is calling the AdMob SDK and calling this function. And more importantly, we see a function here in the AdMob SDK that is supposed to call the set is child directed, which is what Facebook needs to pass that flag. But for some reason, this wasn't happening. And the reason is scrolling to the bottom of the documentation for AdMob, which says that don't do this. This is fine for AdMob as a standalone ad network. But at the time, there are a bunch of stub functions that are in the code that they're giving out to customers, but they don't actually do anything. So when AdMob is configured for mediation, it just ignores the child-directed treatment flag altogether. And that was what was happening. And so it's likely that, in the case of Duolingo, the developers thought that they were doing everything, properly, but because there are lots of, interconnected components developed by third parties and lots of different documentation that needs to be read, they're inadvertently, sending behavioral, sending persistent identifiers for behavioral advertising purposes to Facebook and likely don't even realize it. And so there are several, very serious questions here about, do developers know to look for these type of documents? And more importantly, for larger organizations that are developing software like this, they have compliance processes, but do those responsible for compliance know about, this type of SDK documentation and know how to verify whether or not app developers in their organizations are actually implementing these things correctly? So, so far I've talked about, inadvertent things that we find apps doing to violate privacy that are a result of, misconfigurations, but other stuff we've seen seems to be outright malicious. So we published this paper about a year ago where we decided to use our instrumentation to look for circumvention of the permission system. And specifically, we've come up with a method for automatically identifying side channels and covert channels. So a side channel basically means that you have an app and it's prevented from accessing a protected resource because of the permissions. If the data that it's trying to access is available through some other means that aren't protected by the permission system, that's a side channel. And a covert channel is, you have one app that has the permission and another app that doesn't. Then if they collude, via covert channels, such as, writing to a shared file system, then they can, share the information with one app that otherwise wouldn't have that permission. And so we've built a process for automatically detecting this at scale. So using the infrastructure, we run apps, we see where personal information is being sent, and then we subtract the apps that actually had permissions to access that personal information. And basically what's left are the apps that cheat, so to speak. So apps that are sending data that they didn't have permission to access. So let's look at that. So here are two sets. We have a set of apps without location permissions, and we have a set of apps that are transmitting location data. A reasonable person might expect that these sets are disjoint, but again, in practice, we find that that's not the case, and it's not the case for several reasons. So, one is side channels. So the proc file system on Linux, which is what's running on, your Android phone, it's a virtual file system that has information about the system state, and included in that is networking information, specifically the ARP table, which lists the MAC address of the upstream router. If that's a Wi-Fi hotspot, if it's a mobile device and it's a Wi-Fi hotspot, that information can be used to infer location, which is why collecting the MAC address of the upstream router is now protected by location permissions on newer versions of Android. But what we find is that apps have discovered they can just read this from the file system and avoid asking for permission. So here's an SDK. This is OpenX, which gathers location data. It first checks to see if access Wi-Fi state, which is one of the permissions that's needed to get the MAC address of the Wi-Fi hotspot, whether that's been granted. If it hasn't been granted, then it jumps down below to this other function, get device MAC addresses from ARP. And here it just opens up a file handle to the proc file system and reads it directly. So in this case, it's an SDK that specifically checks to see whether it has permission to access the data. If it does, then it accesses the data legitimately through the Android APIs. And if it doesn't, then it gets the data through this other mechanism. And there are a lot of apps that are bundled SDKs that are exploiting these vulnerabilities. And so we find several different SDKs that are doing this, varying hundreds of apps used by billions of people. And so again, most of these bad behaviors appear to be caused by third-party SDKs. When we see apps that are exploiting this particular vulnerability, it's almost universally from the SDKs as opposed to the core app code. And so what does this actually mean for compliance? I mean, it means that in many of these cases, when app developers are dropping these SDKs into their app to fulfill specific functionality, they're probably not aware of some of the other things that the SDK is doing. And that can, obviously pose problems for them. So, this could be particularly serious because they might be inadvertently misrepresenting themselves in terms of what they do with, information they collect. So, this is, this is under the FTC Act. The FTC can go after companies for deceptive practices by misleading on the privacy policy. There are also various state laws that cover this as well. And so here's an example. This is the Weather Channel app. Prior to, I think 2 years ago, this is what it said when it would ask for location data. It said, using your location allows us to provide you with faster, more accurate weather, period. What they didn't say was that that data is also being sold to various third parties for advertising purposes. And so the Weather Channel was actually sued by the Los Angeles County or the Los Angeles City Attorney. And yeah, and they, I mean, while that eventually settled, they've probably spent a lot of money on the litigation, all because their disclosure wasn't really accurate. In this case, we can't. It's hard to say motives, whether they knew or not. But I mean, it's likely in this case since it was being sold for advertising purposes. But you can see how apps, could inadvertently make incorrect disclosures, and so. You might be, if you're an app developer and you're just putting in a third-party SDK without actually reading all of the documentation, you might end up, not accurately describing your app's privacy behavior, and that might include collecting data that might require consent in certain jurisdictions and not getting it. It might, mean collecting, well, there are all sorts of different things that your app could be doing without your knowledge, which could end up, causing it to violate the law. And so the question is what to actually do about all of this. I mean, I think the main takeaway is, if you're an app developer, read SDK documentation thoroughly, because, you might not think that there are privacy implications for the functionality that you want to embed within your app, but that might not actually be the case. So the other thing is making compliance people aware. So if you're, in a large software organization, as I said before, there are people who are there specifically for compliance. If they don't know what SDKs, what third-party SDKs are bundled in the app, that's obviously a big problem because it's kind of their job to read those documents and make sure that, that the disclosures for the overall app are actually matching what the app actually does. And then finally, there's testing. As I've said, the recurring theme through all of this is much of the time, it's not necessarily malice. And even when it is malice on the part of the SDK and even when it is malice on the part of an SDK, it's likely in many cases that the app developer just didn't know and weren't really in a position to know because the documentation didn't properly disclose the behavior. In which case the only real remedy here, or the only way of preventing this is testing. So, making sure that, before releasing an app, checking all of the network communications to see what data is actually being sent to which third parties, so that you can be absolutely confident that not just your privacy policy is accurate, but that, that the app is, in compliance with relevant laws. And so with that, I'll leave it there.
Thanks, Serge. That was an excellent talk and a tremendous amount of work you crammed in. Before opening things up for the group, I want to ask you a question that I suspect will be of interest to many folks at CITP, which is about how you interact with policymakers and platforms. Some of my favorite conversations we've had over the years, and one of my favorite dimensions of your work is how you've integrated it with regulatory matters, legislative matters, and platform policy. So could you speak to how you manage those interactions and how you think about having impact of that sort with your work?
Yeah, that's a really good question. I mean, one of the frustrations that I've had with most of this, stepping back, I fundamentally think that most of this is a policy issue. So in terms of, the online privacy generally, we know how to solve many of these problems from a technical standpoint. We're just not doing it because the incentives don't exist to do so. Certainly Google could be enforcing, their policies in the Play Store by actually not just, doing static analysis to see whether the app actually contains, SDKs that are otherwise forbidden, but also doing some dynamic analysis, which certainly they're capable of doing, to see what traffic is being sent from apps in the Play Store to verify that, yes, in fact, not only does it use the certified, child-approved ad networks, but they're actually configured correctly so that they're not so that they're configured for, COPPA compliance mode. And, none of that's happening because there's no incentive for it. Google doesn't, Google has no reason to spend money hiring people to, to audit apps or develop software to automatically do it, or even to, outsource that, because there's not really a demand from regulators to do that. And part of to actually answer your question, the problem is a lot of the regulators just don't really have the technical expertise to understand many of these issues. And so that's why I think it's, I see a huge part of my job as, disseminating results to policy folks and not just, going to tech, to security conferences to talk to other people who already understand the issues, but aren't actually in a position to do anything about them. And so that's why, meeting with regulators, I think, is really important. And they know that they need more technical help. Many of them, this is not to say that they don't have technical help. Many of them do. So like the FTC has a bunch of people, the office, OTEC, who do phenomenal work there, but it's 4 of them total for the whole FTC. And so they're overburdened, and they're, certainly aren't briefing all of the lawyers who would be filing cases that have, implications for this stuff, because they just don't have the capacity for it. And so, usually when I'm in DC for various reasons, I'll, part of it is, knowing, people, but I'll send emails to folks at the FTC and say, hey, I'm in town. Can I stop by? If you want, I can, give a 30-minute talk on stuff that's relevant to you. And that's kind of what's, I don't know, from my limited perspective, it seems like that seems to move the needle way more than, sending an email to folks at Google saying, hey, can you fix this? Because why would they?
Well, that's helpful, and I hope folks at CITP think about making those connections throughout their work and getting out of DC from time to time. All right, let's open things up for Q&A. Feel free to ask a question in the chat or raise your hand or whatever your favorite way of using Zoom to ask questions is. If we don't get a question in the next few seconds, I'll just keep peppering Serge with questions. All right, I don't see a taker just this moment, so let me ask one more, which is you have this startup app census, which is based on your work, trying to build a business model around data privacy has proven challenging for folks over the years. That might be quite the understatement. How do you think about the intersection between startup land and data privacy, and how are you trying to succeed where so many others have had difficulty?
Yeah, that's also a really good question. So where we've gone with App Census is, well, stepping back. So the start of this project was 10 years ago when we started building it. Well, 10 years ago, we were just doing, we were doing usability studies, and then it was probably 7 or 8 years ago. That was when I realized, oh, we need to start baking instrumentation into Android so that we can, do more studies in the field and just log data automatically. We basically built this whole fork of Android to allow us to audit apps, but at the same time, we realized that this is ridiculous as this can't be a product. I had some funding from DHS to actually try and, turn it into a product, but it was ridiculous, the idea that we would expect the average consumer to flash a new ROM onto their phone just so that they can understand, whether an app is sharing location data inappropriately. And that's when we sort of got the idea of testing, because we were building this test bed pretty much for research purposes so that we could do measurement experiments, but then started getting lots of emails with commercial interest from, both, security firms as well as, plaintiffs' attorneys, regulators. And so it was clear that like the value is, in this case for privacy, it's the data that we're generating. And so that was sort of the pivot we made, was turning this into, a SaaS product where, and that was the thing, is we've spent basically the past year building this online dashboard so that we can do on-demand testing from the browser, with the click of a button, and then, a few minutes later, export a whole PDF report that we can then sell to, plaintiffs' attorneys, regulators, enterprise customers, that sort. And so, yeah, I mean, like right now we're in a very privileged spot because we just happen to get lucky that privacy is now a popular topic. I mean, I've been, working on privacy for, close to 20 years now, and it's just really, I guess, maybe the past 5 years where it's now a really hot topic and there seems to actually be a market for it. But yeah, I mean, most of the market right now that for the data part of it is, at one end you have the proactive enterprise customers who actually want to do better, and make sure that their apps actually match their compliance obligations. So one example, early on, we worked with Fortune 100, a large multinational company that has apps that support some of their hardware products, and they have a dozen different apps that are in the Play Store, but they have one dude who's in an office in London who's responsible for their global privacy policies, and this is a lawyer who has absolutely no technical training, is responsible for making sure that the privacy policies in all of the, that are available in the different countries that they operate all match what the apps actually do. And so it's ridiculous that, this one person can actually do that job. And so, we generate reports for, so that lawyers can understand what the tech is actually doing. And then, we have, they're the ones, they're watchdog groups. So our first customer was Consumer Reports early on, and we still have an ongoing relationship with them. And then, yeah, regulators. So there's, the one end of the enterprise customers who want to actually stay on top of compliance and want to, compete on privacy. And then the other end, there's, the enforcement part of it, watchdog groups and, lawyers. But really, I guess to actually answer the short answer is, I'm still not sure there's a consumer market. There's clearly an enterprise market and an enforcement market because there's a consumer demand for this stuff to be, better. But I don't think there's an actual consumer market yet for consumers who would be, taking lots of extra steps, to do things like this.
Okay, so your observation about the lack of a consumer market dovetails nicely with the first question that popped in. I'm just going to go through the questions in order. The first that popped in from Mahir, who's the director of our clinic and led drafting, in fact, of our COPPA comment. Mahir asks, can you speak more about the incentives that you think will move Apple and Google to take app privacy more seriously? Regulatory fines, laws, private lawsuits, for example?
All of the above. I think also, though, there does appear to be a consumer, as I said, there's a consumer demand for it. So, look, Apple's already doing this, right? They're competing on privacy now very publicly. Maybe this is different in, on the East Coast, but certainly here, there, in San Francisco, there are billboards for Apple, for iPhones that advertise the privacy features right now. There's a whole ad campaign. So, Apple seems to think that they can compete on that right now. Others who have decided that they can't, that's where, I guess, regulation comes in and enforcement.
Are there specific types of regulation or enforcement that you'd like to see? For example, would you like to see the FTC more resourced? Would you like to see sort of some form of new federal privacy law? What do you think about those directions?
I have several different thoughts. One, yes, the FTC needs to be, there's there are two options. Either the FTC needs at least an order of magnitude more resources, or there needs to be a private right of action, because right now privacy is essentially an unfunded mandate. The FTC only has the resources to bring, 1 or 2 COPPA cases a year. I'm currently like talking with them. It's funny. Like I'm discussing things with them that, I brought to their attention like 3 years ago, and it's just because they have a ridiculous backlog, because they don't have the resources. And so, if right now under COPPA, only the FTC or state attorneys general can sue companies that are violating it. And so if the FTC, is the only one that has this authority and can only bring 1 or 2 cases a year, basically that signals to companies who are not being sued that they have, a license to violate the law with impunity. And so I think that needs to change. If nothing else, just having adequate enforcement for the existing laws, I think would be a big step forward. But, in terms of better laws, the main thing I would like to see is something similar to GDPR, where data collection requires a legal basis. And, that needn't always be consent. But if there isn't an applicable legal basis for data, collection, then it should need consent. I'd like to see that, and I'd like to see it actually enforced, so that people, because only then can people actually make informed decisions about privacy. If you have no control over what data is used for once it's released, you can't really make any meaningful decisions. So yeah, I would like to see that. Another thing is, the problem with notice and consent is that there's no standardization whatsoever. Imagine going to the grocery store and having to read, whole essays by manufacturers to figure out what ingredients were in foods and whether there were allergens in there. Of course, that would be ridiculous. No one would be able to do that competently. And those who would actually, spend significant time. That's why we've standardized nutrition labels. Recently, in the past, the CFPB was what, 2009, 2010. Now we have financial disclosures that are, in a standardized format so that consumers can more easily compare one, financial product to the next, or, are less likely to overlook, terms that could have very, adverse consequences for them. And so, because of the standardization, that's really helped. I don't know why we haven't done that yet for privacy.
All good directions, and I hope the federal government takes those directions seriously. Okay, we've got a couple more questions here. Next up, one of the participants asks, how could we encourage more computer science majors and experts to occupy positions as policymakers, since it seems like a big part of the issue is lack of technical expertise among regulators? And let me add to that as a corollary, how as a faculty advisor do you think about supporting members of your research community and getting more involved with government policy?
Yeah, those are all really good questions. In terms of getting more involved, I think, one thing is that, I noticed from like a lot of colleagues just don't really care about the policy aspects of their work, because it's not a part of their job. It's not anything that, most departments look at in terms of tenure cases and stuff like that, in terms of, how many, how much rulemaking has your research impacted, or how many angry letters from Congress critters have cited your research. Those aren't really metrics that departments track, which is unfortunate. And I think that I guess is the question limited to academia or or industry as well? It would be nice, I think, maybe having congressional fellowships where they have more rotations of technologists coming into organizations, whether that be from people in industry or people in academia to advise. But again, it's all about resources and priorities. As long as this isn't really a big priority, there aren't the resources available to make it happen. As an advisor, similarly, as an advisor, I certainly encourage my students to take policy-related internships. I think more of that should occur. But again, it's economics. So, most of those internships are either unpaid. And so, that versus the choice of going to, Facebook or Google for a summer and making a lot, twice, 2 or 3 times more than your stipend is, for most, that's why the policy stuff isn't as attractive. And so I think, again, we just need to make it a priority and point resources at it. Make it, an important, measure of impact.
I couldn't agree more, especially for when my tenure case comes up. All right, so we have one last question in the Q&A, which is, what's your perspective on the widespread iOS Facebook SDK crashes that in the last year were revealed to be running in a lot of apps without being specifically initialized? It turns out that it required a plist value to keep it off, but yet had to be included as part of Facebook login that a lot of products need.
I'm reading this myself.
Yes. I vaguely remember this when it happened at the time. There was a bug in their SDK that led to app
We haven't
crashes.
been looking, so I guess I should have said at the beginning, the reason why we've been focused on Android is just because it's open source, and a lot of this requires baking the instrumentation into it. And that's really why, we've done some work on iOS early on. I had a couple of students who jailbroke a phone and then we're using that to decrypt binaries just so that we could do static analysis on iOS apps. But I don't think I've really looked at iOS in any depth, and that was probably 5 or 6 years ago. I honestly don't know I don't really have a strong opinion on this, just because I'm not, yeah.
So that's certainly a direction for any enterprising, aspiring researchers on the call. iOS is somewhat understudied in comparison to Android.
Oh, yeah.
So, if you're looking for projects, there's something to think about.
Yeah, well,
there's a reason it's understudied.
It's
crazy
understudied.
hard. All right. So seeing no further questions, I think we should wrap things up there. Serge, that was a terrific presentation and great Q&A. Thanks so much for joining us. And don't be a stranger. I'm sure we'll be in touch over.
Yeah. Thanks for having me. This was fun.
Yeah. All right. Well, take care, and take care to all the CITP folks who are on the call, and we'll see you next week.